Hello friends, I am Vivek Kumar, Assistant Professor, Department of Electronics, Faculty Engineering, Gurukul University, Haridwar. Today we are going to discuss triangular wave generator. That is another circuit in analog electronics. So this is the circuit of triangular wave generator and the output waveforms. It consists two operation amplifier A1 and A2, one feedback capacitor to A2, resistance R1, R2, R3, R1, R2, R3. So essentially, operation amplifier A1 is acting as its mid-trigger circuit, and operation amplifier A2 is acting as an integrator. So basically, this is a combination of its mid-trigger and integrator. So the output of operation amplifier A1 is simply a square wave having the value or peak value plus Vsat and minus Vsat. The output of operation amplifier A2 is basically a triangular wave which is the integration of square wave. So output of A1 is going to input of A2 basically. So input of A2 is a square wave, so its output will be triangular wave. Now this is the circuit. Operation amplifier A1 and A2 are connected to resistor R1, and the output of integrator, that is A2, is fed back to the input of A1, that is mid trigger, through resistor R2. Now as we know, the output of operation amplifier switches when VID, that is voltage difference across non-inverting terminal and inverting terminal, changes. That is, if VID is greater than 0, output will be plus Vsat, and if VID is less than 0, output will be minus Vsat. So let's say in starting at t equal to 0, the output of operation amplifier A1 is plus Vsat. We can take minus Vsat also. So I am starting from plus Vsat. So plus Vsat is going to operation amplifier number A2. As soon as the positive voltage is coming at input of A2 at inverting terminal, capacitor starts charging. In negative direction. So output of A2 will be negative going ramp. It is a negative going ramp. Now this ramp is increasing in negative direction, and it is feedback to the operation amplifier number A1 through this path. Now let's say at some point A, showing here, at this point what happens? This is the transition point, and if the negative going ramp extend beyond this line, the transition occurs. Transition at input of the operation amplifier occurs, and its output changes accordingly. So let's define this point V ramp. How this point will be defined? So there are basically two voltage source at this potential divider feedback network. There is a resistor R3, there is a resistor R2 also. So at this point, the potential of operation amplifier is minus V ramp, and at this point the potential of operation amplifier is plus Vsat. So we can define this potential using superposition theorem. That is, we can calculate the potential of point P using superposition theorem. Two voltage sources are applied here, 1 and 2. So we can easily calculate the potential of point P. So I have drawn here the circuit. So this is plus Vsat, this is R3, this is R2, this is minus V ramp, this is the point P. So we can calculate the potential of point P. So applying superposition theorem, that is operating one source at one time and killing all the sources, next time applying second source and killing all the sources. Similarly, so when V ramp is 0, let's say, when this potential is 0, the potential of point P is given as Vsat divided by R2 plus R3 into R2, because this point is a zero potential. Again, when we kill this source, we have to operate this source. So now, when minus V ramp is operating, output can be written as minus V ramp divided by R2 plus R3 into R3. So this is potential of point P equal to Vsat divided by R2 plus R3 into R3 plus minus V ramp divided by R2 plus R3 into R3. So when V ramp is 0, this term comes. When Vsat is 0, this term comes. So now we can easily calculate. For transition, Vp should be 0. For transition, Vid should be 0. That is, potential of P point should be 0, because inverting terminal is already at ground. So we have to compare through 0 potential. So for transition, potential of this point should be 0. So now we can easily manipulate, putting Vp equal to 0. So when Vp equal to 0, this is minus V ramp is equal to minus R2 upon R3 into Vsat. So similarly, friends, when transition occurs, that is, potential of this point become negative. So Vid becomes positive here. This Vid, that is potential difference between non-inverting terminal and inverting terminal, becomes positive. So as soon as this becomes positive, output will be minus, Now, as a capacitor charging in negative direction, this curve is going beyond this point. So at potential when Vp equals to 0, transition will occur, because if it is going just beyond this line, the potential difference, that is VIT, that is potential difference across non-inverting terminal and inverting terminal, becomes less than 0. So as soon as this potential difference becomes less than 0, output will change, and it will change from plus Vsat to minus Vsat directly. So now the output of operation amplifier number A1, that is V0 dash, becomes minus Vsat. This becomes minus Vsat. So now capacitor will charge in positive direction, because this potential is now negative. So capacitor will charge in positive direction, that is we obtain this graph. So similarly friends, this will charge up to potential plus V ramp, and at potential plus V ramp, transition will occur again similarly, because as we have seen just, as this curve extended beyond this line, the potential difference of operation amplifier number A1 becomes greater than 0. So as soon as it becomes greater than 0, output will change. So at this point, output will change from minus Vsat to plus Vsat. And similarly, output will occur, and it will be going indefinitely, and we will have an output of triangular nature, this nature, that is output of operation amplifier number A2, that is V0. So now friends, we have calculated minus V ramp up to time period 0 to t1. So at point t2, when the output A1 switches from minus Vsat to plus Vsat, at this point, minus Vsat to plus Vsat, what happened? Similarly, we can calculate, or we can write V ramp is equal to minus R2 upon R3, the same term, the same value, into minus Vsat instead of plus Vsat. So this is giving this value. So V ramp is equal to minus R2 upon R3 into minus Vsat is equal to R2 upon R3 into plus Vsat. So now we can calculate the peak to peak voltage of output of triangular wave, that is V output peak to peak, and this is equal to, simply friends, this voltage and this voltage difference, that is plus V ramp minus V ramp, that is 2 times plus V ramp, that is equal to 2 into R2 upon R3 into Vsat. Into R2 upon R3 into plus Vsat. Now we can calculate its time period also. So for calculating time period, we can integrate the output of integrator. So we can write for half cycle, this is V0 is equal to 1 upon R1C1, the time constant, integration of V input, that is minus Vsat dt from time 0 to t by 2, that is for half time period. I have written here minus Vsat because we are integrating to from 0 to t by 2, and from 0 to t by 2 the input is, you can see here, it is minus Vsat. When it is switching from minus V ramp to plus V ramp, so V input will be minus Vsat, so you can easily calculate V output is equal to Vsat divided by R1C1 into t by 2, where t is the total time period. So now this can be written as T is equal to 2 times R1 C1 V output peak to peak upon V sat. So from this expression we can calculate T equal to 4 times R1 C1 R2 divided by R3. So frequency can be easily calculated. Frequency is equal to 1 upon time period. So this is giving R3 upon 4 times R1 C1 R2. So this is the frequency of the output triangular wave. So now based upon this we can solve one numerical problem that is written here. Assuming that for circuit shown in figure we have just discussed for triangular wave, R1 is 100 kilo ohm, R2 is 10 kilo ohm, R3 is 20 kilo ohm. Capacitor C1 is 0.01 microfarad, and assuming plus V sat is equal to plus 14 volt minus V sat equal to minus 14 volt for the operation amplifier. You have to determine the time period, the frequency of output triangular wave, peak value of square wave, and peak value of triangular wave. So this can be easily calculated, friends, because we have the relation T equal to 4 times R1 C1 R2 upon R3. So now this can be written here 4 times 100 kilo ohm into 0.01 microfarad into 10 kilo ohm divided by the resistance R3, that is 20 kilo ohm here. So this is giving 2 millisecond. So this is the time period. So output frequency is calculated as f naught equal to 1 upon t, that is 1 upon 2 millisecond, that is 500 hertz. So output of this triangular wave will be 500 hertz. The peak value of the operation amplifier is simply the saturation voltage, that is plus minus V sat, that is plus 14 volt to minus 14 volt. And the output of triangular wave, that is peak value of triangular wave, can be calculated by formula we have just obtained, Vp, that was V ramp is equal to R2 upon R3 into plus V sat. So this is giving 10 kilo ohm upon 20 kilo ohm into 14 volt equal to 7 volt. So the output of triangular wave oscillates between minus 7 to plus 7 volts. Now one more point here, just like we have discussed in a square wave generator, the capacitor starts charging from 0, but here it is shown from plus V ramp, that is output is discharging directly from plus V ramp. So friend, because we have discussed in a square wave generator that for regular waveform the charging point from 0 to t by 2 or 0 to t has been removed here. So we can have the regular waveform, and it is from plus V ramp to minus V ramp to plus V ramp to again minus V ramp, and so on and so forth. So this is the similar output. To remove the dissimilarity, charging or discharging from 0 to t by 2 or 0 to t has been removed here. So this is the working of triangular wave generator. Thank you, friends. Thanks for watching.